Well, hey, how's it going? This is a little review for our upcoming test. So we're going to start with this old worksheet I have that goes with the same text we have, but an older version. So you'll notice there are parts that have X's in them or crossed off, but I think it should be a pretty good review, so we'll go ahead and give it a shot. Let's start here with the first things, some fill-ins here, some multiple choice. It says chemistry may be least useful in studying. We got choices of matter, synthetic fiber, volcanoes, or medicine. I would say volcanoes since that's more of a geometry thing. So I'll put C here. The science most concerned with studying the composition of materials is, well, that's easy, that's chemistry. Put that B. One of the most important tools in chemistry is the periodic table. Although a scale and a beaker are also important. But periodic table is the best choice. A manager of a pharmaceutical company, in addition to being trained in management, would most likely be trained in chemistry. To determine the cause and effects of chemical pollution in a large body of water would require chemists who are trained in, let's see, we got chemistry and biology, aeronautics, chemistry and geology, and physics. I have to go with chemistry and biology. Mr. Cloud would be so proud. 6. Many items of clothing would not exist without technology chemistry has developed in the area of synthetic fibers. Everybody likes a rayon suit. So there you go. There's our first 6. 5 major branches of chemistry. Ooh. I might have to pull up my notes for this one. We got physical chemistry, analytic. What else we got? We got biochem. We got organic. What was the other one? One moment while I look through my notes. Let's see. We got inorganic. Yeah, whatever. It's inorganic. That's the last one. Alright. So now we have our first page more or less done because at the bottom here I got a big X. Scientific method. You know, real scientists don't really do the scientific method. So why even learn it? Okay, so we're on to matter and energy. Section 1-2. The weight of an object is least at, let's see, the bottom of a deep mine shaft, a sunken vessel. Ooh. High altitude or sea level. Well, I'd have to say the higher you go, the less you weigh, so we'll go B. High altitude. Inertia is most closely related to a body's mass. They're almost synonyms. So we'll go B. 3. The chemical energy that substances possesses because of their composition and structure is a kind of kinetic energy or potential. We'll say potential. If you break those bonds, energy can be released. The ability to cause change is called energy. A. The particles in a solid are packed closely together, very far apart, constantly in motion, able to slide past each other. That would be A. Packed closely together. 6. A change in temperature causes the most change in volume of a gas. C. See, some of these things I don't know how well, if you really have to know these for the test, but they're good, you know, practice for future things and just basic scientific knowledge. 7. An experiment which determines the density of water is investigating physical properties. B. 8. Chemical property of oxygen, that is that it most abundant combines with hydrogen to form water, boils it. as density. I'd say B is the only reaction it's talking about. 9. A dark gray solid is heated in a closed container and purple vapors are given off. These purple vapors condense to a large gray powder on the top of a container. This is an example of a physical change called sublimation. 10. Road crews spread salt in the winter because the salt, as it dissolves, releases enough heat to melt ice. This indicates a endothermic reaction? Nope. Gas being produced? Nope. Exothermic? Yeah. Must be calcium chloride they're referring to, not NaCl. Chemical potential energy stored in reactants is released in exothermic reaction, released in endothermic, converted to kinetic energy, endothermic converted from electrical energy to chemical energy. I would say would have to be A, since it's released. Exothermic. Gets warmer. Now, a lot of those that you won't see on the test, but whatever. Still, it's good science practice. Okay, on to section 1.3. All of the following are mixtures with the exception of brass is a mixture, air is a mixture, baking soda, that's a pure substance, concrete is a mixture. Water is composed of 11.2% hydrogen and 88.8% oxygen by mass, is a pure substance, chemically combined. Pure substances, solutions, and elements all contain phases or mixtures or hydrogen are this one's throwing me for a loop. Solutions and elements and pure substances are mixtures, but elements not a mixture. Pure substances, so we can get rid of that one. Well, it's like elements contain phases, but solutions, do solutions contain phases? I don't think so. I'm going to have to say homogeneous. That's a tough one. I don't really like that question. 4. Pure substances can be solutions, check. Heterogeneous, no. Elements, mixtures. So we would have to say not B, can be. I would say pure substance can be element C. A compound composed of 3 elements is salt, water, sugar, carbon dioxide, sugar, carbon, hydrogen, oxygen. Okay, complete the following. Well, this is NaCl, this is H2O, and this is CO2. So those only have 2, but this one has 3. Okay, on to the chart now. So it says, complete the following data table, checking either homogeneous, heterogeneous, depending on the type of substance. Iron ore, we would say that that is homogeneous. Quartz, homogeneous. Granite, that's heterogeneous. You can pick out the different elements. Pancake syrup, homogeneous. Vegetable soup, heterogeneous. Salt, homogeneous. Water, homogeneous. Nitrogen, homogeneous. Depending on the picture of the iron ore would determine. So I'll just put a little question mark there because you'd have to really look at a picture of it to decide. Go on to 15. Identify and give examples of 2 primary types of homogeneous matter. Well, we could have salt water, which is 2 things that are like a solution. That's the best example of a homogeneous mixture. 2 primary types. I'm not sure what the other primary type is. I mean, alloys, could say that too, which is a pure is a mixture of that's homogeneous, like brass. I'm not 100% sure on that one either. All right, it's the last page, 1-4. We're already 9 minutes into this beast. Horizontal row on a block of the periodic table is called a periodic. Symbol for an element in period 2, family 3. Let me look at the table. Period 2, family 3, that would be boron. Let's double check. Yeah, period 2, family 3 is boron. An element that is a good conductor of heat and electricity is called a metal. Non-metal. So things that are good conductors are metals, and things that are bad are non-metals. Common elements and their symbols: Al, calcium, Mn, manganese, nickel, phosphorus is P, cobalt, silicon, hydrogen. Define a metalloid. Metalloids are both, metals and non-metal properties. They fall in the periodic table. So like if this is our periodic table here, right? Metalloids are going to be right along the stair step here, so you'll find them in these portions right there. They can be used as semiconductors. So that's the big thing about metalloids, is they can turn on and off electricity, usually with temperature, but useful in all kinds of electronics. Name 3 characteristics of nonmetals. Let's see, they're brittle, no luster, or dull, and non-conductor. Metals: luster, or shiny, ductile, or malleable. And then finally we have conductor. Alright, that's it. So hopefully you took the time to do that. It was an easy way to get some more practice for a test. Alright, that's it. Video 1 for chemistry complete. See ya.